This is A Square Maths Made Easy Academy. Welcome to my YouTube channel. So today video I'm going to talk about the part 2 aspect of set, indices and logarithm. In my last video I was able to solve 1 to 10 questions and well simplified. Then today I'm going to continue from 11 to 20 questions, and that is why I target word by word 2. Are you there now? Are you ready with me? Now I want you to watch the 11th question. Now we are going to talk about the 11th question, which is question number 11. Now the question says, evaluate all square root of 160 r squared plus square root of 71 r squared r raised to power 4, 71 r raised to power 4 plus square root of 100 r raised to the power of what? 8. Now options are A, we have 13 r squared. Option B, we have 13 r raised to power 3. Option C, we have 13 what? R. Then option D, we have what? 13. Now I want you to watch this particular question. This is a question that has to do with multiple word square roots. Now the question says that we should evaluate all square root of 160 r squared plus square root, all square root again, 71 r raised to power 4 plus the last square root, which is square root of 100 r raised to the power of what? 8. Now when you see this kind of question, the first thing that you are going to do is to start with the smaller word square root, and the smaller square root is this very particular one. So which means I'm going to start with square root of 100, then r raised to the power of what? 8. Are you with me now? Remember what I taught you, the meaning of square root. Square root means to the power of 1 over what? 2. So which means this thing is 100 r raised to the power of what? 8. Close the bracket. Everything is to power 1 over what? 2. Are you with me now? Then what do we do in order to get the indices of 100? I want you to understand this, that you can use what we call long division. So you agree with me that 10 can go. Are you with me? 10 by 100 will give us what? 10. Then 10 also can go to give us what? 1. So which means the indices of 100 is 10 into how many places? 2 places, right? Now if that is the case now, can you now see that the question is already solved? Now let's go. So I'm going to have this as equal to, here is 100, and what is 100? 10 raised to power 2. Are you there? Have it in mind that this 1 over 2 is affecting everything inside the word bracket. So which means for me to dissolve this now, I will now multiply the power by 1 over 2. Then I'm done with 100. Then we now multiply and move to what? R. R is r raised to power 8. Still multiply the same by 1 over what? 2. Are you with me? Can you now agree with me that 2 down here will cancel 2 up here? So what remains is 10 raised to power 1. And what is 10 raised to power 1? Hope is 10. Then I will now multiply. Now you can agree with me that this is r, right? And the 2 can go into 8. How many times? 4. Then 4 times 1 will give you what? 4. Now with the smaller square root, the answer is 10 r raised to the power of what? 4. So we are done with the next smaller one. Then we now migrate to the one that is bigger than that smaller one, and that is this. Are you with me now? So how do we dissolve it? I want you to watch again. I will now introduce square root of what? 71r all to the power of what? 4. Now be careful. I hope here is plus, right? Now this is the smaller square root. Have it in mind that we have already dissolved it. What is the answer? The answer is 10 raised to 10r raised to power 4. What did I say? 10r raised to the power of 4. Then I will now go here and put 10r raised to the power of what? 4. Now if you continue, you are going to have square root of, now since the powers are the same, are you with me now? Now add the coefficient. Add the what? Coefficient. How do we add the coefficient? 71 plus 10 will give us 81. Are you with me now? Now you pick one of the values of r here, which is r raised to the power of what? 4. Now the same thing applicable here. What did I say is square root? It means power 1 over 2. Now which means I'm going to have 81r raised to the power of 4, close the bracket, all to the power of 1 over 2. Are you with me now? Then how do we get the indices of what? 81. Now let's apply long division. Have it in mind, this is 81. What do you think that can go? Do you know that 9 can go? Are you there now? To give us what? 9. Another 9 can go to give us what? 1. So which means 81 by indices form is 9 all to the power of what? 2. Now let's go back to where we are. So which means we are going to have this as, what is 81? 81 means 9 to the power of 2. Remember, this 1 over 2 outside, which is the power, is multiplying everything inside the bracket. Then open the bracket. I will now say to the power times 1 over 2. Are you there? Then I will multiply and move to what? R. I have with me R raised to the power of what? 4. Then still multiply it by 1 over 2. Oh my goodness, something is about to happen here. Are you there now? What is that? 2 down will cancel to what? Up. Remaining 9 raised to power 1, which is equal to 9. Then I will multiply. Now, do you agree with me that 2 can go into 4 without a remainder? 2 here is 1 and 2 here is what? 2. Then 2 times 1 will give you what? 2. It becomes r raised to power 2. Can we multiply? If you multiply, it will now give you 9r raised to the power of what? 2. Are you there now? Now, this is not the final answer. Don't be in a hurry to conclude that the answer is 9r raised to the power of what? 2. Now, what next? Is the larger bracket, which is the final one. What did I say? The final what? Bracket. Then watch. I will now bring it like this. All square root. Then what is the value? The value is 160r raised to the power of what? 2. What is here is addition, right? Then don't forget that the whole thing here, we have solved it already. What is it? It is 9r squared. I will now put here 9r what squared. Are you with me now? Then, in as much as the powers of the r are the same, can we add it up now? So that I'm going to have something like this. Now watch. All square root of 160 plus 9 will give us 169. Will give us what? 169. Then bring one of the r, which is r raised to the power of what? 3. Then my question, how do we dissolve this 169? Now have it in mind that 13 can go without what? A remainder. So I will have here as 13. Go by this will give us 13. 13 again we divide to give us what? 1. So which means 169 is the same thing as 13 all to the power of what? 2. Can you see that we have already got to what we are looking for? Then watch. I will now consider this as 169 r raised to the power of 2, close the bracket, square root means power 1 over 2. Are you there now? Then do we know what is 169? Yes. What is it? 13 all to the power of what? 2. What did I say? 13 all to the power of what? 2. I will now put here as 13 raised to the power of 2. Then multiply it by the power, which is 1 over what? 2. Because this time I'm trying to open the bracket. Then I will now go ahead. So this one is r, right? R raised to the power of 2. Don't forget again that it is still times the power, which is 1 over 2. Now, can you see that the question is already there? How? 2 down here, we cancel 2 up here. 2 down here, we cancel 2 up here. Oh, talk to me, everyone. What is the answer? 13 times what? R. And what is 13 times R? Beautiful. The answer is 13 R. Now, do we have something like this in the option? Oh, yes. It is option 1, C. So that is how to solve it. Are you with me now? So having gone to the 11th question, let's quickly move to the 12th what question. Still watch. Are we there? We are watch this. That is all. Remember, we are solving 20 questions. My last video, what I solved under set logarithm indices problem was first 10 questions, and it is past question. And this question will also be good for those that are going for professional exams, those that are writing West African Examination Council's exam, those that are even taking what we call ultimate exam in Nigeria. That thing is called what? JAM. And those that are also taking professional exam for an interview. I believe this will help you out. Now, having solved number 11, I want us to move to question number 12. Are you ready now? Question number what? 12. Now look at the question. Oh my goodness. What is the question? Number 12. Now, number 12 says, if set A is n squared plus 1 such that n is a perfect square. N is a perfect what? N is a positive. N is a positive, not a perfect square. N is a positive integer. N is a positive integer, and 1 is less than or equal to 1, while n is less than or equal to what? 5. Now, this is for A, and set B is given as 5n such that n is a positive integer. Are you with me? Positive what? Integer. N is a positive integer, and 1 is less than or equal to n, less than or equal to what? 5. Now the question says find A intersection what? B. We are looking for what is common between set A and what? Set B. Now what are the options? I want you to watch. Options A says set of are you there? 5, 10, then 15. Then option B says set of 5, 10. Option C says set of 2, 5, what? 10. Are you there? Then talk to me. Option D says, oh my goodness, 5, what? 10, 15, and what? 20. Now, what do we do first? First of all, we have to describe this set first. If you don't describe it, you cannot know how to list the members. Are you with me now? How do we describe this? Watch. N squared plus 1 is a set of what? A. This dot dot means such that n is a positive integer. And watch here, n is greater than and equal to 1, but less than or equal to what? 5. I repeat, n is greater than or equal to 1, but less than and equal to what? 5. Or the other way around, you can say 1 is less than or equal to n, and n is less than or equal to 5. But the rightful pronunciation is that you must always start from the unknown to the what? Known. Now the unknown is n. Are you with me? Then to say if 1 is less than or equal to n, it means that n should be greater than or equal to what? 1, but less than or equal to what? 5. Are you there? Then what are those members where n is greater than or equal to 1, but less than or equal to what? 5. Let's list them first, then we resolve this now. They are, we start from 1, followed by 2, followed by 3, followed by 4, followed by 5. I will stop with 5. The reason is because n should be less than or equal to what? 5. But you cannot conclude that this is the final answer. Do you know why? They have given you that n squared plus 1. You should solve it. How do we solve it? I want you to watch. When n is 1, it means that anywhere we see n, remove it and put what? 1 in order to get the answer. Oh yeah, watch. When n is 1, it becomes 1 squared. And 1 squared is 1, right? And 1 plus 1 will give you 2. Are you with me now? We move again when n is what? 2. I'll put 2 here. It becomes 2 raised to power 2. And 2 raised to power 2 is what? 4. And what is 4 plus 1? It will give you what? 5. Are you there? Then we'll move again when n is what? 3. Talk to me. 3 squared means what? 9. And 9 plus 1 will give you what? 10. I will have here as 10. We now move again when n is 4. What is here now? 4 squared. What is 4 squared? 4 squared is 16. Are you there? Then 16 plus 1 will give you what? 17. Then lastly, when n is what? 5. It becomes 5 squared. What is 5 squared? It is 20 what? 5. And 25 plus 1 will give you what? 26. Now all this that we have solved now, they are what we call members of set what? A in terms of this expression. Are you with me now? Then permit me also now to go to set B. Now watch. Set B says 5n is a member of set B such that n is a positive integer and n is greater than or equal to 1 but less than or equal to what? 5. Are you there now? Remember, I did not talk about positive integer. What are positive integer? They are just sets of positive whole numbers. Set of what? Positive whole numbers. That starts from 1, 2, 3, 4 continuous. And that is why they give you the analysis here using inequality, which means you have to start with 1, are you with me? And stop at what? 5. The reason is because there is an equal to. Then let us analyze this now. Remember that what is given to us is 5n. Are you there? Let's solve it the way we solve set what? A. When n is what? 1. Let's start with 1 again because it's still talking about positive integer. When n is 1, it means that anywhere we come across n here, put 1. I will say 5 times 1. And what is 5 times 1? That is 5. We now move again when n is 2. Are you there? It becomes like this. We said 5 times 2. Are you with me? Which is what? 10. We now move again when n is what? 3. It becomes 5 times 3, which will give us what? 15. We now move again when n is 4. It becomes 5 times 4, which will give us what? 20. Then finally, when n is 5, it will now give you 5 times 5. And what is 5 times 5? Which is what? Which is what? 25. So which means the members of set A, what are they? We have 5, 10, 15, 20, and 25. Then can we solve the question now? Watch. What is the question? Find A intersection B. The word intersection means what is common between set A and what set B. I want us to watch. A intersection B now, which is the final answer. Let's solve. There is 2 here. There is no 2 here. So 2 is not a member. Now there is 5 here. There is also what? 5 here. So 5 is common. 5 is what? Common. Can you see in the option now? I can never choose this. So which means it lies between option A, option B, and option what? C. But let's continue. Now the third element here or number is 10. Do we have 10 here? Oh yes, there is 10. So 10 is also a member. Are you with me? Then the next one is 17. Do you have 17 there? No. The last one is 26. Do you have 26 there? No. So which means the only common element that exists between set A and B is 5, 10. Now let us observe it. Do you have it in the option? Yes. So which means the correct answer in the option is option what? B. Are you with me? So you mark this. That is how to solve problems like this. Having satisfied question number what? 12. I want us to migrate to question number what? 13. Remember I said it's just 20 questions and that one is part what? B. Oh yeah, watch. So let us move to question number 13. Now the question says, if x is a factor, is what? A factor of 18 and the y is a prime number. Prime numbers between 2 and what? 18. Now the question says, comma, what is x intersection y? We are still looking for the common element. Now what are the options? Option A says 2, 3, 6. Are you there? Option B says 2, 3, 9. Then option C says 2, 3, 18, and option D says 2, what? 3. Now watch this. I want us to take this one bit by bit. Remember the question says, if x is a prime factor, oh my goodness, prime factor of what? 18. Now, I mean, if x is a factor of 18, I mean factor of what? 18. Now the question is, what are the factors of 18? It means that those numbers that can go with that 18 without what? Remember, they are what? Factors of 18. I want you to observe that 1 can go, 1 can divide, 2 can what? Divide. Are you with me now? Then can 3 divide 18? Yes, 3 can what? Divide. But 4 cannot divide. Can 5 divide? No. Can 6 divide? Yes, 6 can go. Are you with me now? Can you see that now? The only number that we have now here is 1, 2, 3, 6, and itself, which is what? 18. This is what we call factors of what? 18. Are you with me now? So which means the value of set x, these are the values. We have 2, 1, 2, 3, 6, and comma what? 18. Are you there now? Now, if we have exhausted that one, we now move to set y. Look up, everybody. Set y says is a prime numbers between 2 and what? 18. Now, the question is, what are prime numbers? Now, watch. Prime numbers are a set of numbers that has two factors. That has two what? Factors, itself and 1. I repeat, set of numbers that has what? Two factors, itself and 1. So which means anything that exceeds more than 2 factors, it is never a prime number. How? I want to start with 2. 2 is a prime number. Are you with me? Do you know why? 1 can divide and itself. Can you see it has 2 factors? Then 3 also is a prime number because 1 can divide and also what? Itself. But 4 is not a prime number. Be careful. How? 4 has more than 2 factors. How? 1 can divide, 2 can divide, and itself. Can you see it is more than 3? So let us move again now to verify the prime what? Numbers between 2 and what? 18. We start with 2 is a prime number. Don't start with 1. 1 is not a prime number. Do you know why? Because it only has just a factor. Then let's continue. 2 is a prime number. Are you with me? 3 also is a prime number. Are you with me? Then what again? 4 is not a prime number. Then 5 is also a prime number. Then 6 is not because it has more than 2 factors. Then 7 is a prime number. Are you with me now? Then what again? 8 is not a prime number. 9 is not a prime number. 10 is not a prime number. But 11 is a prime number because it only has itself and 1. So which means 11 and only 1 can divide it. So which means it is a prime word number. Then 12 is not a prime number. 13 is all a prime number. Wow. 14 is not. 15 is not. 16 is not. Oh, finally 17 is also a prime number. Now this is just a prime number. But what are we looking for? Having known the element of set x, the element of set what? Y. Then what are we looking for? What is common between the two? Are you ready now? Now let us observe it. There is 2 here, there is 2 here. Accept what? 2. There is 3 here, there is 3 here. Accept what? 3. There is 6 here, no 6 here. There is 18 here, no 18 here. So the only number that exists here that is common between x and y is 2, 3. Do you have that in the option? Yes, the correct answer is option what? D, which is this very particular one. Are you with me? Now let's move to question number 14. Let's move to question number 14. Now